Today we are discussing symmetry. Okay, what is symmetry? Symmetry means identical shapes. When the geometrical figures are said to be symmetrical about a one line, it must satisfy two conditions. The line divides the figure into two identical parts. On folding the figure above this line, the two parts of the figure exactly coincide. Look at here, I will show one. Here is a sheet of paper. This is a shape of a rectangle. When I fold this line paper into two, okay, here I fold through this line. These two pieces are identical. Is it? One is coincide with the other, isn't it? So we can say that these two sides are symmetrical figures according to this line segment. This is a symmetrical line, and these two parts are identical figures or symmetrical figures. Suppose I fold this figure paper just like this vertical form. There is also, when I fold this, it is identical. These two parts are identical according to this line segment. Thus this is known as the unsymmetrical line, and these two parts are symmetrical figures. But I cannot, these are rectangle shape, so I cannot fold this through this diagonal wise. We cannot get that symmetrical figure. Look at this. One is outside. These two pieces are not coincide. So this rectangle shape is not symmetric according to the diagonal. Okay. Look at here. This is a shape of a square. When I fold this lengthwise, both the sides are according to this line segment. Both sides are identical. Suppose this is the symmetrical line. These two pieces are coincide each other, so these two are symmetrical figures. When I fold like this, look at here, then also these two pieces are identical according to this line segment, that is symmetrical line. When I fold this line in diagonal wise, here also this shape is, that is the square is symmetric, because according to this line segment is symmetrical. Then you can again fold this second diagonal through second diagonal. Here is also these two pieces are identical, that is coincide each other. That means this square has through a square we can draw four line of symmetry. Okay, for the triangle rectangle we have to draw only two line of symmetry. Now look at the lines of symmetry for a line segment. That is the we have already studied. When we draw a perpendicular bisector for a line segment, that line perpendicular bisector divide the line segment into two equal pieces. So that we can say that the perpendicular bisector is the line of symmetry of a line segment. And now for what is the line of symmetry for an angle? That's also we have studied. When we draw a angle bisector, that angle bisector divide the angle into two equal pieces, isn't it? Two equal measurement. If the angle is 60, 30, 30 will get. That means these two angles are symmetric according to this symmetric, and the angle bisector is its symmetrical line. Now moving to triangles. Isosceles triangle. Look at here. Here is an isosceles triangle. These two sides are equal. This is a base angle. When we draw a line of symmetry through the vertex angle, we will get two. That is, this line of symmetry means the perpendicular bisector of this side. The perpendicular bisector of angle of vertex is also known as perpendicular bisector of its baseline is BC. That means these two pieces are identical. Look at this. Here is this is an isosceles triangle. When I draw a perpendicular bisector or a line of symmetry, these two angles, look at this, these two angles are coincide each other. That means this is the line of symmetry of this isosceles triangle. We can draw only one line of symmetry for isosceles triangle. We can check through this. Look at it. When I draw a perpendicular, is it both two sides are equal? This one is bigger than this one. Suppose another one, the third side, if we can also try it. Is it identical? No. Look at this. This is a smaller one. This is bigger. They didn't go inside though. So for the isosceles triangle, we can draw only one line of symmetry, that is perpendicular bisector of vertex angle. Now moving to second triangle, equilateral triangle. Look at this equilateral triangle. For equilateral triangle, all the three sides are equal, all the three angles are also equal. That means we can draw three perpendicular bisector, and these three, that means three line of symmetry can be drawn. Look at this. And this is a model of it, equilateral triangle. Look at this. Both two sides are equal, and we can try for these two other two vertex also. There is given some four-dimensional figures, and their line of symmetry for all the four sides for this figure. It's a quadrilateral, all the four sides are different, so we cannot draw line of symmetry for this one. It's a parallelogram. Parallelogram has no line of symmetry. That's why, because when we take draw a line of symmetry, just like I have prepared the triangle model, you can try it also. Okay, parallelogram has no line of symmetry. Rectangle has two line of symmetry. Rhombus has two line of symmetry through its diagonal only. Square has four line of symmetry. This is a kite shape. It has one line of symmetry. Trapezium has no line of symmetry, but isosceles trapezium has one line of symmetry. Just like look at here, this is a arrow shape. Here is also I prepared an arrow shape. We can look at this. Just like when we draw a line of symmetry, these both two sides are equal. That means this is also a symmetrical figure. Here alphabets are drawn, and the line alphabet A, H and O. A has only one line of symmetry, H has two line of symmetry, O has two line of symmetry, vertical and horizontal. I think these line of symmetry you have drawn in the last year as an assignment. Just like here are some figures, you can try to draw the line of symmetry using scale. Okay. And I will give these questions from this exercise 11A. It is an assignment for you. Try to do it and submit when you submit your answer sheets of annual examination. Okay, this is an assignment for you. I repeat again, this exercise 17A, there are 10 questions are there. These have to do this assignment. All the questions you have to try. The clues are here. This part is on the theoretical part. This part you get the answers for these questions and try to do it, and bring your answer, that assignment, when you submit your answer script of annual examination. There is a mark for that. Okay, next section is reflection. Reflection means you have studied in the physics. This is a mirror image. That is, you can look at here, this is a mirror. When a candle is in, if we have keep in front of that mirror, we can see the image of that mirror. How much distance we are keeping this candle, that much distance back we will get the mirror image. That is known as, the same distance will be the how much distance the actual original shape is from the mirror. The mirror image is also that much distance back of that mirror. You can also check your seeing your image in the mirror. Okay, that's only. Now we have discussing the reflection of axes. This is only in your 9th standard section, so we will neglect this section. Okay, there is no need to do now. We will do this section in 8th standard or 9th standard, and this is reduced from your syllabus for this year. And this is a rotational symmetry. This is also not for your exam, for this year's syllabus. Okay, this much is from this chapter. That means we are completed all the portions of this year 7th standard portions. Next class onwards, we must have revision chapters, exercise revision of the examination portion. Okay, thank you.